Unison is to take a fresh look at programming and see whether there's anything that we do change about like how programming languages work or how programming works, so that we can do more of that stuff and make it delightful.
Remember, the full episode is only available to our Patreon members. Hello, welcome to the DevTools-fm podcast. This is a podcast about developer tools and the people who make them. I'm Andrew, and this is my co-host, Justin.
Hey, everyone. We're really excited today to have Rúnar, one of the co-founders of Unison Computing. So Unison is a programming language, which will be our topic today. I'm incredibly excited to talk about it. We've mentioned it several times on the podcast in the past. But before we dig into that, Rúnar, you want to say hello to our audience and tell them a little about yourself?
Hi there. Yeah, glad to be here. I'm Rúnar. I'm one of the co-founders of Unison Computing, which is making Unison, which is a programming language and a developer platform, mainly for, in future, mainly for making distributed systems. But it's a very unusual language with lots of cool features. We call it a friendly programming language from the future because, number one, it's not fully in the present because it's it's not where we want it to be, but also we think that this is where programming is going in the future.
Yeah, Unison seems like one of those languages where anytime there's a conversation about the future of programming, it is the language that seems to come up, and there are so many features that make it different. Do you want to try to give a 50,000 foot view for our listeners of what are the things that makes Unison the programming language special?
Yeah. So, so it's purely functional. And so that's kind of unusual. And, there are lots of things that are unusual, but are also unusual in other languages like Haskell or Smalltalk or whatever. But the thing that makes Unison completely different from any language is two things. Number one, code is it's not text. It is an immutable data structure. So your code base, lives. It's literally a database that lives either on your disk or in the cloud or something. And then the other part of this is that code is content addressed. That is, we don't reference, so under the hood, Unison doesn't reference dependencies of functions and types by their names or name spacing or whatever. It uses a hash of the implementation. So it really has, every piece of code has an unambiguous global address in this sort of infinite address space.
Cool. So is the hash based on the actual shape of the thing? So it's if two people wrote two functions that are actually the same in shape, would they share the same hash theoretically?
Yes. So the hash is computed by first removing all the names and replacing them with placeholders, and remove local variable names and stuff like that. And then we just hash the syntax tree. And so, if you wrote a function that does the same thing as someone else's function, that might have a different hash because your implementation might be slightly different. But if it's literally the same implementation, modulo the names, or indentation or something, then it's gonna have the same hash. Just the other day, I was writing a function. I was I better add this function to the base library because it's super useful. And then I go to add it to Unison, and it's oh yeah, I'll gladly add this function for you, but it also has this other name. I'm oh, okay, somebody already wrote that.
And that's kind of an effect of the more functional style of programming, right? Because it's you're making these very generic reusable things, and that happenstance might just happen because you're doing very small units of programming.
Yeah, that's true. This kind of situation where you have the same hash for something is much more likely to come up in very abstract code, where you're, like iterating over a list that doesn't care about the type or is polymorphic in the type, and generally things that are purely functional and don't have side effects. But even stuff that has side effects, would still have hashes.
Something I like about this content addressable system is that it means that renames are like free. You can rename anything, and there's ultimately like almost no consequence to doing that.
Yeah, that's right. So the names are really just metadata on the code base, and so the code base is basically a big hash table. It's a map from hashes to the code, and then we can attach all kinds of other stuff onto the to the entry, things like what are the names for this thing, and you can have as many names as you want for for a function. Like I like to like the optional type where it's like it could be present or not. Like in my code base, I like to call it maybe, but other people like to call it option. And so I just have a little library that just has names, which are my preferences. And renamed. Somebody renamed fold right. It used to be called fold R, and I was like, no, that's too sort of obscure. Let's call it fold right. And so we renamed it in the base library, and nobody's code breaks. Everything just works still because everyone's referencing everything by hash.
How does that manifest? I mean, are there communication issues that crop up from the fact that like things can have different names and it doesn't necessarily matter? I mean, I know you have type signatures for everything, which is like sort of a source of truth, but
yeah, it can happen that something gets moved, and then you go and you reach for the library and you're like, oh, where is this function that was here like in the last version? And then it's been renamed. But Unison keeps the history of everything, so you could go back in history and see where things were changed and stuff like that. And so you can get like a historical name for something and go back. So it's browsing the history currently is kind of janky, but we're hoping like in the future that we can make that experience really nice.
This makes me think of something else that's somewhat related, is that so if you play with Unison, I guess you can check stuff into Git if you want, but like the code is stored in a database, as you'd said. So it seems like versioning would happen very different. You're just talking about histories. So what does versioning your code look like within Unison?
Yeah, so the Unison Code Base Manager is a tool that we're developing, and that is the thing that actually takes care of history and branching and versioning and things like that. And so since our code is not text, we actually can't use Git. We've used Git in the past for just like storing code bases on GitHub, but it's just a big binary blob and GitHub can't see inside of it. But the Unison Codebase Manager, it has this sort of tree structure in it, and so the tree contains namespaces, and there's sort of punning on namespaces where namespaces can also be branches. And so you can like fork a namespace into another namespace and then like do some work there. And then, when you're done with your work, you can merge it back into your main namespace. So it's pretty flexible in that regard. But like every namespace keeps the entire history of that namespace. And the namespace has a hash. And so it has a history of all the hashes of the namespace. And yeah, collaboration happens where, you pull someone else's namespace and then you can merge them.
So you mentioned this Unison Codebase Manager. I think this is a pretty different concept from like most other languages, where most other languages it's just like you maybe have like a compiler that you run and then you have an executable. With Unison, it seems like you do most of your work through that Codebase Manager. So could you kind of explain what it is and like the different things you use it for?
Yeah. So in most languages, you have a big mutable bag of text files, and then you proceed to mutate your text files and you submit it to like the compiler, if it's a compiled language. Obviously, if you're working in an interpreted language or something, then this doesn't apply. But instead of doing that, in Unison, what you generally just end up working in like one buffer. So you work in like a single text file. I just have like a couple of text files that I work in, and I keep submitting those to the codebase manager. And so the way it works is that it will just like watch whatever directory you started it in, and then you work on like any file with an extension .u. If you save such a file, the Unison Codebase Manager, UCM, will wake up and parse and check that file and grab any definitions that you've put in there. And if it doesn't have those already in the code base, then it'll say, you can add these or whatever. And so there are commands in UCM to like add and edit and remove definitions, both for types and for functions. And so the workflow is really like, you make little changes in like a single buffer, and then you submit that. It's very much like, if you're working in Git and you would be like making a commit constantly, like every little change that you make. But the upshot of this is that your code base is always like in a working state. Like no, that's not okay. It is true, but like you can't break it, but you can put it in a state where things might be ambiguous. Like for instance, something might be referencing a different hash than you wanted to. Like you change the definition of some name, but that change maybe hasn't propagated everywhere. But the codebase manager tries to walk you through that. There's a command called to do, and it'll tell you like, oh, you have a name conflict. Here's how to resolve it. So it's a different workflow from most programming languages.
Yeah, it's cool. Just the design of Unison gives all these really, really interesting properties. It's like a lot of the challenges with like source control, using Git or whatever, you're like sidestepping those because the language is so fundamentally different. Content addressable, stored as data, but it comes with its own trade-offs. Like, so you're essentially, you have to build an experience that is, not Git like, but like some kind of thing where you're like continually contributing, you're having versioning and doing all this stuff sort of behind the scenes. And then thinking about like, there are unique things where people who might be really used to, browsing files on a file system might find it a little bit harder to say, all right, how do I browse around UCM to see like what code exists and all that. So it's like, what are you doing for the story of just like perusing your code base and kind of understanding what's written and all that?
Yeah, well, there's, you can browse around using UCM, but it's a lot like, using the command line to browse a file system. But there's also a UI. So if you type UI in UCM, then it'll bring up a user interface in your browser that you can use to browse your code base and see what code is there and read documentation and things like that. And that has the same interface as Unison Share. And so Unison Share is sort of like our, sort of hub where you can push code and, collaborate and like share your code with others.
Yeah, so let's drill down into that more. So like I was browsing some of the share pages, and it's really interesting that like it's like full-fledged documentation. It has like running examples. You can like drill down and see like the actual code of things. Everything's hyperlinked. Like it's a very interesting experience. So like for a person who doesn't know anything, is documentation built into the language, and does like Unison encourage you to document things?
Yeah, well, actually, we don't encourage you to document things. We probably should try to do that somehow. But yes, documentation is written in Unison. So Unison has a documentation syntax where, you just write a documentation expression. You open it with two curly braces, and it's sort of like a markdown-like syntax, but it's just syntactic sugar for a Unison expression that calls some functions. And what you build is a value of this type, doc, and Unison Share and like the local UI also just, they have renderers for this type. And so you can just go in and, if you look at a doc, it'll render it in like, pretty HTML. And any code that you put in there, like you can put like code examples and stuff. You put like triple backticks or whatever, and you can put a code example. And, that code that you put in there will be, it'll be real, like live code. And so, everything is referenced by hash. And so all of the definition or the dependencies of that code will get hyperlinked to like the hash that you're referencing. And then you can click on that and see what the definition of that is.
What just like, it always blows me away anytime I revisit Unison is just like how ambitious the project is, how much stuff that y'all have done across the entire language and the shared service. I mean, I know there's probably still a ton of work to do, but like this is a tremendous paradigm shift. And I don't know, I'm like grinning like an idiot because it's like the most cool thing. I just want to stop and ask like a meta question is like, why did y'all build this? What inspired you to take this path? Yeah.
Utter insanity. No, it's so most of us, the founders or the we who work at Unison Computing, we many of us have been programming since like the 80s or 90s, and programming is just like, I don't know, when you're first starting out, you're like writing little programs or whatever. It's like delightful and amazing, and it's this exhilarating experience. And then you go out into the real world with your skills and you want to like build real systems. And it turns out that like building systems is terrible and tedious. And the tools you have for this are like, like how do you, deploy a service like in a managed cloud infrastructure or whatever. It's like, it's this kind of stuff that you need to do. And like how you do it is like some bullshit. It's not like, you're not using the programming language to like talk about how your like processes are communicating. Like I was working like at a large corporation on the West Coast, and I was like writing, protocols that use like JSON and parse like stuff that has to go between microservices. And I was just like, what am I doing? This is such a waste of my time. And like everybody's time. And it's like, I don't know, 80 or 90% of everybody's time was just like done. It was spent like writing this sort of boilerplate nonsense that is like not in the programming language. And so the goal, or what we're wanted to do with Unison, is to take a fresh look at programming and see whether there's anything that we do change about like how programming languages work, or how programming works, so that we can do more of that stuff and make it delightful. And so like what I want to do is to be able to like write a program that describes like my whole system, and then to run that program is to deploy it. And that's what we're trying to do with Unison Cloud.
Yeah, so speaking of Unison Cloud, one of the features of Unison, or I guess two features of Unison, you have this sort of like first-class notion of distributed computing. So it's like you have an example on your site that looks kind of like a Spark job, where you just like do a big map reduce over a bunch of different processes of a big set of data. And then you have some distributed storage solution. I didn't dig into that too much, and maybe you can tell us a little bit about that. But one of the questions that I had sort of related to this is like, you're just rethinking a lot of like fundamentals about how do you approach building a programming language, and that's like a lot of work. And then you're also digging into the very hairy world of like distributed systems and all that stuff. So really would love to hear more about distributed systems, but also is like, why is that problem in particular the thing, like something that you're adding on to this? Is I guess it goes back to what you were saying earlier about you just want to build systems.
Yeah, it is, sort of the nature of the beast that like when you go out into, like the real world and do programming, you're generally not writing code that just like talks about what one machine is doing. I mean, in the era of like shrink wrap software, and granted, some programmers are still like delightfully still there, like they write, little programs that they sell. But most of us are like out there building systems that are like lots of different services that need to talk to each other. So they're distributed systems, and like even I want to say like even client server programming, like browser backend programming is also distributed programming. And so we're always building the systems where things need to talk to one another. And like at that boundary where you like leave one machine and have to talk to a program that's running on a different machine, there's like this impedance mismatch there. There's like all of this work that you have to do just to sort of make that happen. And like traditionally what people do is like, you can do RPC, where, you pre-deploy the code and then, you reference the code that you want to call on the other machine somehow, but you have to agree on like what that code is going to be beforehand. There's message passing, but then, you have to design some protocol. You have to like, I don't know, write JSON parsers or, protobufs or finagle or whatever. You have to do all this stuff. And it's kind of brittle as well because like versioning of these things and like backwards compatibility, all of that stuff has to be taken into account. And like if you're working in a typed programming language, none of that stuff is managed by the language or the type system. And then the third thing is like message buses or whatever. But again, like the message format has to be agreed upon. You have to program it in a sort of different way in order to like, you're putting messages onto the bus. You're not just like calling functions. But, with Unison, to make another computer do something, you tell it, here's a hash of the code that I want to run. And, you go do it. And then if it doesn't have that hash, I can send you the code that hash represents. And then if it has some dependencies, I can send you those as well. But ultimately, I'll get to a place where like we agree on what the code is, and then you go run it.
Yeah, it's such an interesting way that you guys have chosen to solve it. Like we've had another guest on. He runs a project called TRPC, which is like this elaborate thing to get basically the same thing to happen where it's like, oh, we have type checking across everything through this simple interface, but there's still all that like complexity burden underneath. With Unison, it's like beautiful that it's literally like, oh, I was running this locally, but now I want it remote. And you just say remote. And like, because of the content addressability and the way the whole system works, it's just like super simple, just a function call.
Yeah, so yeah, that's right. The capability of doing remote stuff or distributed stuff is always just like a function call away. It's literally just a Unison library that you call, and it constructs some under the hood it uses some continuation, delimited continuations and stuff, but then there's some interpreter for that which then goes and runs it on a real distributed system, or doesn't. Like it could run it locally on your laptop, and it's the same code.
So if someone was familiar with like the Erlang or Elixir ecosystem and like OTP, it's like, how does this compare with something like that? Or are you, I guess I should say before I ask that sort of question, have you messed around with OTP or read about it or anything?
I have not.
Okay.
I'm only sort of vaguely familiar with Erlang. But Erlang does have a lot of these kind of capabilities where, you can like hot swap code, and you can like tell another node what code you wanted to run and things like that. So that's very cool. But Unison is, it's typed, and that's one thing. So then, you don't have to like, contact like a node somewhere and like send it a message to say like, oh, here's the code that I want you to run. But it's literally just like you put the code that you want to run in parentheses and call it and send it to a function. And that's all type checked, so that you can't call some code that like doesn't type check.
Yeah, one of the things that's happening in the Elixir ecosystem anyway, and I'm trying to keep up with that, is they're talking about like bringing types to Elixir. And one of the things that they are saying is basically like, we're basically never going to type event messages, because it's like Elixir, Erlang, based around these processes that communicate to each other. Like basically, we're not really going to type this boundary. And it's just like something you get for free out of the box with Unison. Well, free, relative speaking, but I mean that's it. It's huge. That's insanely powerful.
Yeah, I mean, I want to say that like I think Erlang is a beautiful language, and I really enjoy it. But I've only used it very little, but it's awesome. Like making these little distributed systems in Erlang can be delightful.
So maybe just like for some more basic understanding, when you're building a Unison program, like what is the artifact that is actually running? I mean, do you compile it down to an executable? And then let's say you had, a distributed system that you were trying to build. What is the artifacts that you're deploying to these other systems? Like in the beginning, is it like you put a Unison interpreter on there and you configure Unison as like, hey, here's how you can connect to this other machine or whatever, and then like just connects, or like how does that work?
Yeah, well, it sort of depends. So, if you're just like running code like on your laptop or whatever, the artifact that is executing is Unison sort of bytecode, and so we have. We compile to this sort of intermediate form, and then that runs on our runtime. You can also sort of compile to like standalone bytecode, so you don't have to have UCM running or whatever. So it's sort of like the Java model where you have like some bytecode in a file, and then you can tell you can start up the virtual machine and have it run that bytecode. But also like in the works, and it's just like coming very soon. Like I saw the PR today, the pull request. So we have a native backend for this. So then it will compile to native code on whatever machine you're on, and it does that through shed scheme. So Unison will generate shed scheme, and then the shed scheme compiler will compile it down to native code. And we have a just-in-time compiler also in the works, so it'll compile it just in time. But if you want to like deploy to a distributed system or like to the cloud or whatever, like yes, you can have Unison nodes that you've like deployed to your internal cloud or whatever with Kubernetes or Docker or whatever else, using the same methods that you do today. And then, you can just rely on the fact that every one of those nodes is running Unison, and you could send it stuff. But like that's going to be a lot of work. And so what we're working on is Unison Cloud, which will be our managed infrastructure, basically, where we'll just give you a library, and then you make a function call to that library, and that will deploy your code to our cloud.
Keeping with this pattern of like everything's just Unison code, which is fun.
It's Unison all the way down.
I love that.
No, it's actually Haskell under the hood at the moment.
Yeah, so Unison isn't written in Unison yet?
No, Unison is mostly written in Haskell. I mean, a lot of stuff is written in Unison, but UCM is written in Haskell.
So before we move on to like the cloud stuff, because that's I saw some super interesting demos around that. I want to drill down into some of the other benefits you get from the content addressability. There's this one doc in your documentation called the Big Idea that like runs through all of the like really cool use cases. And we were just talking about builds and type checking a little bit, and those docs mentioned that the nature of content addressability unlocks some pretty cool things for builds and type checking. So could you go into those?
Yeah, well, one of the coolest things that it unlocks about builds is that there aren't any. So your managed code base, it's like always in a working state. And so you sort of gradually and incrementally update it. And it's always built. So there's no build process as such. And so, you add some definition, it gets compiled, and, then you might have like an integration test, you run that, and then once that's done, like the code works. There's no, going to get all the text files again and like parsing and compiling and making sure that everything works. Because like, why do programming languages generally have builds? The reason why is that the code, the end product, needs to be able to know where to address other code, right? So then, you got to run the build so you can like compile down to the syntax trees and like the final form. And then you got to make sure that like the addresses of like where the code lives is plugged into the right places so that, when something makes a function call, it goes to the right place. But since Unison, is always addressed by hash, then all the code, like every function, has a unique and deterministic, unambiguous global address. So there's no like linking or build step.
Yeah, I think one of the baser things here is that like compilers don't know what code you've changed generally. Or they might have like some plugins like, oh, a file has changed, I need to recompile a file or something like that. But like generally, you might have some caching system behind the scenes, but it has to like process this entire file to like know all this stuff that's happened. Whereas like you're saying, hey, I'm going to add this one method or change this one method or rename or whatever. And it's just like that one thing that's all sort of like linked together. So it's really interesting.
Yeah. But like not to take away from like lots of people have done very cool work about, regarding incremental compilation and, lots of IDEs, like the main IDEs, they have very sophisticated compilers where they're incrementally compiling so they can detect the stuff that you've changed. So, don't want to take away from that. But, at the end of the day, most shops will have like a continuous integration step where you run the build and you make sure everything works, and you run all the tests. And that's another thing with purely functional programming, if you've run a test and it passed, you never have to run that test on that code again. It's a complete waste of time to like run all the tests again. So what UCM does is that it caches the test results, and it will only run a test again if the code that it depends on actually changed. That is, if the hash of the test changed.
That's a super cool concept that like basically builds, type checking, tests for your functions, they all only have to happen once. Like the amount of like time and compute that must save is probably immense. And probably another one of the effects of that is as your code base grows larger, you don't feel a larger code base. Like if I have a TypeScript code base that's like 40,000 lines, I'm going to feel those 40,000 lines while I'm working. But in Unison,
that's a good point.
All the work's done as you go along. So like, as you said, like your code base is constantly in this like perfect form. And that form is like, oh, type checking, building, testing is all done. It's an afterthought. You don't have to do it again.
Right. Yeah. So very incremental, and you end up working in like little sort of fiefdoms of your, like if you have a big library or something, like you end up working at like one namespace, and it feels very sort of isolated from like the rest of the big project.
Have y'all played around with just like visualization tools? It seems like given that Unison the code is in a data format, it's like, I don't know, showing a DAG of a particular like, I don't know, function or whatever. It seems like it'd be a really like almost trivial thing to do. I'm just curious as like,
Yeah, that would be cool.
How accessible is this sort of underlying data structure for how the code is actually stored? I mean, can you just like...
It's SQLite, so you can,
nice.
I'd say it's very accessible. If you can write SQL, it's super accessible. So yeah, I mean, you could go into, you write a little tool that like does a query of the database and like draws a dependency graph or something. Unison at the moment, UCM has like commands for asking the dependencies of something. It'll give you like a list of the shallow dependencies of a thing or the dependents of a thing. And I think it also will give you transitive dependencies. I don't remember if it can do that, but
is there like a meta API?
That's an excellent question. Oh man, I really want that. No, we don't have that at the moment, but no, that's sort of in the works. So Unison has this system of abilities, which is like our effect system. And so, one of the abilities is IO, one of them is like non-determinism, and like exceptions is one ability, things like that. And so one of the abilities that I really want is like a code-based ability. So you should be able to say like, what is like what are the hashes for this name, or like what definitions are in this namespace, and well, take all the definitions in this namespace and move them over here, or so this sort of manipulating the code base programmatically. So it's not like meta programming as such, like you're not generating code, but you're talking about the code base programmatically.
Something we've talked about on the podcast before, and I've spent a lot of time doing, is writing code mods. So it's like usually build time scripts that like parse your code and try to like transform the AST in some way. So it's like, I don't know, having that in Unison seems like it'd be also a really interesting and powerful thing.
Oh yeah, and like on top of that, it would be really great to have a representation of the Unison code in Unison, so that you can actually like manipulate the AST.
Yeah,
with Unison itself.
It's so wild, my mind's so blown. You mentioned abilities earlier, and I sort of wanted to re-highlight that. I think algebraic data types or algebraic effects, I should say, are something that a lot of purely functional languages try to pursue. In my experience, like in my limited experience, some of them are pretty awkward, but I thought Unison's was pretty interesting. And you mentioned earlier too that like exceptions are represented as an ability. And I think this is a really cool point and something that like is hard to highlight, because when you're writing like code in TypeScript or Java or whatever, exceptions are this like extra vector out of a method. It like has some other behavior that does something else, and it's like this other state to think about. And
it's like always there.
Yeah,
right? You can always throw an exception.
So you never really know if that could happen or not happen. And it's like, but if you have it like an ability, it's like in the type definition. That's a tremendously powerful mechanism. So it's pretty interesting.
Yeah. And really like abilities are like, they're all kind of like exceptions. So, for instance, like the IO ability, what it's really sort of doing is like it's throwing an exception to like the runtime. And then the runtime says like, oh, what is this? And like, okay, you want to print line. Great. Let me go do that. And then it transfers control back to your program. So it's sort of like, it's delimited continuation. So it's like throwing an exception and then giving, part of the exception is like, here is where I was in the program. It's like a pointer back to the program. And then the runtime calls the continuation and on the program goes.
So what does asynchronous code look like? I mean, I'm assuming asynchronous stuff is largely tied to abilities. So it's like if you're making a network request, you're going to have an ability to go do that. But is abilities how you do asynchronous code?
Yeah. Yeah. So asynchronous, sort of multi-threaded code is tied to the I/O ability, and so there's a function called io.fork, and you give it some code. You give it an unevaluated thunk, which means that you just like put. It's a function that takes no arguments, basically. So you give it one of those functions that takes no arguments, and you just pass it to fork, and it'll spawn a new green thread, and run it. And we have mutable variables that you can use to communicate between, sort of synchronization points between threads. We have transactional memory, so that you can use, atomic operations on both mutable variables and mutable queues and mutable arrays, things like that, to communicate between threads.
So going down the line of other things that are unlocked by this content addressability, another interesting thing to me is how like dependencies work. Normally when you're creating something, like I'm primarily a JavaScript developer, my dependencies have to like be perfect. Like they like conflicts are a thing I think about constantly. Pulling in extra ones like can actively make my experience worse, but in a Unison code base, pulling in extra ones seems to be like, that's the default. That's like kind of what you want. You can like represent your code base at like any point in time because it's very easy to pull in the dependencies from any point in time and have that code. So how does this content addressability make dependency conflicts much less of a problem?
Well, the way it does it is that dependencies are represented at a fine-grained level. So it's at the level of the individual hashes. So your code just depends on some hashes, like the hashes that it actually uses. And as long as those hashes are present in your code base, which like your code wouldn't compile if it didn't, but then you can call those hashes. And it's never the case that you're like, oh, I have a version of like a version 1 of a library and then a version 2 of a library that like transitive dependencies that are transitive dependencies of some other libraries. Like, oh, I depend on library A and library B, and they both depend on library C, but they depend on different versions of library C. So this becomes a problem in a lot of dependency management systems. But in Unison, there's no problem at all because they have those functions that you're using from those libraries, that your dependencies are using from those libraries. They may just have different hashes, and so they can just live happily together in your code base. They'll just have different names, and then if like a type changed between one version of a library and another, then you'll never be able to like pass one off as the other. You'll never be able to call, a function that expects one version with, the other version. You'll just get an ordinary type error if that happens.
Like this also kind of means that like it's far easier to deploy like backends that have like multiple versions and are like there forever. Because like I could in a world where I'm like calling Unison code on the front end, my front end app could like all be calling V1 and there's no problems, and then V2 comes around and then there's still no problems because it's just all there all the time.
Yeah, and even like, if your front end and back end are both Unison and you're using like the Unison internode protocol for them to talk to each other, then the front end can literally just tell the back end, like, this is the code I want to call. Like, oh, it says like, here's the hash. Like, I want to call this function. And if the back end doesn't have it, you can say like, well, give me the code. And then, give it the code and then it hashes it. It's like, okay, this matches. Great. I'll run it.
Can you write your front end in Unison? Is that a thing?
I mean, yeah. I mean, you can write, console applications in Unison. Like, there's no GUI library as of yet for like writing a GUI front end. We don't compile to JavaScript as of yet, and so we can't do that right now. But we can look into whether there's a Shez scheme compiler to JavaScript, and if that's the case, then we're running in the browser as soon as that merges. And so you can imagine a future where like you're writing your web front end and like your back end in the same language and like even in the same file, and then they can just talk to each other with a function call, as if they were all running on the same machine.
That's the dream. It gets rid of so many different tools and so much configuration. It would just be amazing for that to happen.
Yeah, there are too many tools and too much configuration.
Well, that's it for this week's episode. Remember, the full episode is only available to our Patreon members. Thanks for listening.